you. Thank you. Welcome. Boy, I'd like to say that I brought the beautiful weather from California, but it was nicer when I got here. So I want to thank Andy and I want to thank the Inspur crew for the opportunity to speak today. I'm going to spend a few minutes and talk about open sourcing and the role that open sourcing has played in delivering innovation to our industry. Before we do that, I'd like to kind of lay the groundwork and talk about different types of organizations that are involved in developing specs and standards and driving open sourcing. The first being your traditional standards organization. This is an organization where many people come together. They have various agendas. They write a detailed specification. That specification is typically written long before any products are actually built. Furthermore, the authors of that specification really have no obligation to build a product. And so we don't know the timeline that a product will be forthcoming after a specification is written. I'll give you an example of that. Most recent specification from IEEE was the 400 gigabit Ethernet specification. Started back in 2015. Was finally released at the end of 2017. And we're actually just starting to see products introduced into the market here last month. So 2.5 to 3 year cycle. Not bad, but for an industry that's moving very quickly and growing at a tremendous pace, that's awfully hard to keep up with technology when our standards organizations move at a different pace. Another example of a standard that you're very well aware of, and that's the standard 19-inch rack. I don't know if you know the history of that, but back when America was building railroads across our country and installing the telegraph system, we had a bunch of relays that helped bring the signal down the wire, also to control those railway switches. By 1922, a small company, American Telegram and Telegraph Company, you may know them as AT&T, actually put all those switches into a rack. And that became very popular, standardized that rack, and by 1934, it became the EIA 310 rack standard. So we've been living with that standard for over 80 years now. And I want to bring that up as an example because sometimes with standards, it takes a long time to adopt a standard in development, and sometimes it takes even longer to get rid of it. We're kind of stuck with those things. So, it isn't necessarily the best type of organization for us as an industry moving forward. Another type of organization is a multi-party sourcing agreement. This is where we bring consumers and suppliers together. They define a specification. They agree on building that compatible product. Works pretty well. They can move very efficiently, but it doesn't necessarily bring a lot of innovation and ideas into it. It's very specific for a particular product. I'll use the 400 gigabit Ethernet again as an example. The standards body created a wonderful standard for 500-meter distances. It was insufficient for the distances that the industry needed, specifically for 2-kilometer and 10-kilometer distances. And so it was a multi-party agreement, a multi-party sourcing agreement that actually got together and within a matter of months was able to agree on a compatible set of products for the 2-kilometer and 10-kilometer distances. But what I really want to talk about is open source projects. These are projects where we bring together participants that are both contributors and consumers. We work together on new specifications, on new products. When those products are successful, they become de facto standards. And the beauty about de facto standards is that other people want to be a part of that standard. They want to deliver products and build products based on that. They want to innovate on top of that. So it naturally drives innovation. It naturally drives the addition and inclusion of new players and new companies. And that's why open sourcing is so popular. It's not a new subject, though. Open sourcing has been around for 3 decades. Andy's presentation was a much better slide than mine in the time frame for some of these open sourcing projects. But I can relate back to the 1980s when we had a bulletin board service that was offered on a platform called CompuServe. And we could get on that and share ideas through that bulletin board service. Later on, Linux was formed as an open source project in 1991. And by the year 2000, the Linux Foundation was formed to try to organize this collaborative effort and this broader, much larger community, thousands of people that were working in this open source project. By 2011, we actually added several new projects. One of those was the OpenStack project launched by Rackspace, and we launched the Open Compute project, the organization that I'm with. By the way, this is also the same time frame that the ODCC project was launched in China. So again, our open sourcing has been around for 30 years. It's not new. A lot of people get involved in open sourcing because they think that they're going to save money. And honestly, they do. There's some truth to that. But, and we have lots of survey results that indicate that this is the reason that companies get involved initially. They want to drive down that cost, and they get involved in an open source journey. As they go down that journey, they quickly learn that there's actually other benefits that they're going to receive as a part of being involved in this journey. They quickly learn about the benefits of speed or performance. It's really based on how that company can scale. And again, we heard conversations earlier. Gartner presentation, the presentation Randy, talk about how fast we have to scale as an industry and the difficulties that that we will have in trying to scale our organizations. So the beauty about open source organizations and projects is that we can add people to these projects much faster than we can hire people. And so we can go from a small team inside our company to a team that's twofold or tenfold larger by simply working across the community, find fellow travelers that are interested in the same type of product, the same type of spec, meeting the same type of challenge, and work together in an open, collaborative fashion. And so we create that scale and that size by doing that. And obviously, when you put more people on the project, you also increase your speed. And with speed, you also allow the addition of new features. And so our product may be faster just in terms of time to market, but it's also faster in terms of the amount of features and innovation that we're actually building into it, because we have, again, a much bigger set of developers that are working on this. So that, again, leads to innovation. And again, everybody wants to be part of something. They want to feel that they're doing something wonderful for their company and for the world around them. And so they're happy to share these ideas. And they want to be recognized by their peer groups as being part of this bigger effort and being part of contributing to society. So these great ideas are openly shared. And sometimes they're very small ideas, but when you put thousands of small ideas together, we end up with some really interesting, very innovative products. And what we've learned from companies that have evolved and gone down this path of open sourcing is that they really see the benefits of open sourcing as speed, scale, and innovation. I'm going to talk a little bit about innovation. Let's look back on how we innovated in the past. We relied on OEMs to provide us with products if we were an end user. And we told the OEM what we wanted them to build for us. And the OEM went to the technology partners like NVIDIA or like Intel or like the dozens of other companies that provide core technologies. And those OEMs would decide which of those core technologies they would design into the products. Some of that was based on feedback that they received from these end users. Sometimes not all the end users had an opportunity to influence what went into those products. And sometimes the technologies that were available, even the very best technologies, did not necessarily make it into that end user product. So that innovation pipeline had holes in it. Not everybody's needs were fulfilled, and not all the best technologies made it in to the product. So in the open source community, we have a different innovation model. what we're doing is we're putting the technology providers in the same room and on the same projects as the end users. They're able to collaborate from the very beginning to define new products, define new specs, define new interfaces. It's a wonderful idea, except that when you bring all these end users together and all these technology providers together, it's very difficult to communicate. And if we're not careful, we create a bunch of chaos. And fortunately, we have organizations that help manage that chaos. And I'm going to introduce you to my organization, our organization, the Open Compute Project. We were formed back in 2011. We're a collaborative community focused on redesigning the hardware that drives our industry. We want to make sure we drive it to support efficient compute and keep up with the demands that the infrastructure is requiring, that our businesses are requiring. How do we do that? We do that through creating a collaborative environment, bringing together those producers and consumers to work together on common goals. Together they contribute their ideas. Those ideas result in specifications, result in products, and eventually those products are consumed by this community. We have some wonderful leadership in OCP, and I'll just mention a couple of them. These companies they don't represent their interests, they represent the interest of our industry. And we're fortunate to have a company like Intel, a technology leader for 50 years. They can speak to all those technology contributors, and they help guide us and help us as a foundation understand how we work with technology providers around the world. We have companies like Microsoft and Facebook who help steer the foundation and the community and help us understand how we work with these hyperscale customers everywhere in the world and understand the problems that they face. And more importantly, we have companies like Rackspace who think of them as, let's say, a tier 2 cloud provider. They are a smaller cloud provider. They have a different set of challenges in scaling their infrastructure and scaling their businesses. So we're very fortunate to have the leaders from Rackspace sit on our board of directors. And finally, we have Goldman Sachs is another one of our board of director members, and they represent the enterprise community, as well as the financial services segment, and they're a global company. So we get the advantage of their knowledge and insight to help us steer this open source community to deliver products and deliver benefits and features and collaboration for the enterprise segment as well. But really, most importantly, is our community. And I'm here today on behalf of Inspur, and it's very exciting to have Inspur as part of this community, the #1 provider of cloud hardware in China, the #3 provider of hardware in the world. And it's really important for us to have leaders like this that are part of this community and willing to work with in an open collaboration. Besides Inspur, we have other companies from China that are also part of our community. We actually have a total of 17 companies that are members. 3 of those are mentioned here. And I'll just talk shortly about one of those. Alibaba joined our community a year ago. They have been very instrumental in helping the community develop a couple of different things. The first is they've partnered with Microsoft. They're working on Sonic. Sonic is a operating system or a software that sits on top of open network switches to run their network. So Microsoft team was able to collaborate with Alibaba and literally double the size of their development community through this open sourcing strategy and the work that Alibaba did. That's just one example. We have many, many others. Worldwide, we have 200 companies that are involved in this open source community. Last year, we really had a very successful year. We had a market research company called IHS Market that conducted a survey on our behalf, an independent survey, and they went to our non-board member companies. So these are, and they wanted to measure the revenue that they received, that was shipped to companies. And then when I say non-board members, so I'm not including the volume of OCP hardware that was shipped to, let's say, Microsoft or Facebook. So this is think of this as revenue to the channel. And what they came back and said is we shipped $1.2 billion in 2017. But more importantly, they said that growth, we have tremendous growth for OCP hardware worldwide. And by 2021, we expect that the industry will ship OCP hardware in excess of $6 billion. We have tremendous growth from Americas. We've been present there. But we also, the survey also said is that we have growth in Europe and we have growth in APAC. And I think that that growth is coming right from China right here today. So again, it's very important why we have partners like Inspur that are going to help us achieve these numbers. So that's very exciting. Not only are we seeing excitement and growth, we're also able to now see how technology is being introduced through these open source projects. Back in March, we had a summit in the United States, March 20th. EdgeCore produces white box, bright box switchgear. They announced the availability of 400 gigabit Ethernet switch. And this, again, the same switch that follows the specification from IEEE. But this is the very first 400 gigabit switch available as an open source product announced through the OCP Summit. So now people that are involved in open sourcing projects are actually no longer at a disadvantage. They're getting the latest technology time to market. Likewise, Microsoft announced that the work that they've been doing on cloud storage specs will be launched and made available through OCP. So again, very exciting. Beyond that, we're starting to see the impact that we're having on the industry. SDX Central is a market research company. They produced an industry report that came out recently, and they acknowledged that the work that the Open Compute Project is doing, along with work that the Telecom Infrastructure Project is doing, is in fact really driving standards and driving these initiatives. And it's really exciting to see that recognition for the first time very recently. But we can't do it alone. We work with other open source communities, both hardware communities and software communities. On the hardware side, the one that comes to mind is the Open Power. Very involved in machine learning and AI. We're very happy to work with them. They've been releasing some of their Open Power platforms through OCP, and we continue to look for opportunities to work together. We've had ongoing relationships with the Telecom Infra Project, co-authoring and developing customer premise equipment and edge devices with them. On the Linux Foundation, they have an open network or open NFV project. We're working with them to virtualize a central office using open hardware and open software ingredients, similarly with Cord and OpenStack. So we're working with all these organizations. We want to deliver a complete hardware and software solution to the industry that's open sourced. We do that through a series of project teams. These are groups that we get together on a weekly and monthly basis, quarterly basis. They work on new ideas. They share their ideas. They work on specifications and standards. We have 4 core groups focused on server, networking, storage, and rack and power infrastructure. And on top of that, we actually have 7 other groups. 2 of those are vertically focused. We have a group focused on the HPC segment and telco segment, but we also have 5 other groups that think of that as delivering ingredients that these other groups can use. We have a group that focuses on hardware management to making sure all of the OCP platforms are managed in a similar fashion and presents a similar API to the software orchestration layer. We have a data center facilities group looking at continually improving the efficiency of data centers, both from a cooling and power delivery as well as from operation. Recently, when we announced 2 new projects, our Open System Firmware project, focusing on completely open sourcing what you may know as BIOS, and then secondly, adding a security project to focus on delivering some root of trust features into the hardware. And last project is interoperability. These project teams work together through many different ways that they collaborate. Besides working on specifications, working on new designs, that result in products. We also encourage our community to work with each other and help each other adopt and learn from other experiences. So we encourage our community to create reference designs, to create white papers, to do case studies, and then present those case studies through various workshops, testimonials, seminars, and videos. And you can see the result of that. If you take a look at the data center 10 years ago versus the data center today, we've implemented a tremendous number of changes because we've been working together, not just OCP, but all of these open source organizations. We've eliminated the raised floor. We're using water cooling. We're using direct air to remove the heat. All of these improvements have reduced the CapEx and OpEx expenses of operating the cloud. Not just at the data center level, but at the rack level as well, where we have rack level deployments. And by looking at the entire power distribution chain from the utility through the UPS down to the power supplies, we've taken traditional IT equipment where we had power supplies in each of those devices, and now we're actually taking the power and we're pooling it into a shell. The advantage of that is that we now reduce all those power supplies that were relatively inefficient with a much more efficient supply, but we also have the opportunity to eliminate the UPS. It results in roughly a 17% improvement in power delivery to these rack scale designs. Not only are we dealing at the facility level and at the rack level, but we have leaders like Inspur that are delivering technology at the compute level. Last year, when Intel launched the Xeon Scalable processor mid-year, it was Inspur that launched an open source compute sled for OpenRack called the San Jose Compute Sled. It was literally launched on the same day it was available, and actually all the design files and specifications were available to the industry to go use and adopt. So it's just a demonstration of Inspur and the leadership that they have and how they have embraced this open source community with their products. Not only do they have compute products, but they're working with the community today to come up with better storage solutions, to understand what problems the storage community is trying to solve, and then design products around that, products that address all the various tiering of storage, cold, warm, and hot tiered storage. They're also very active in our hardware management group, and they're embracing a standard written by the DTMF organization. That standard is called Redfish. Redfish actually provides a RESTful interface for hardware management. The Inspur team is working on a BMC implementation of that. They're going to run it through the validator, and then they're going to roll that out into their products. And I expect that the Inspur San Jose motherboard compute will probably be the first product that will actually support this Redfish standard. So very excited to see that. Not only that, but I expect that all the products that will come out in the future from Inspur will also support that. To help our community understand what's truly open, we've identified a couple of different logos. One is the OCP accepted. By the way, the San Jose motherboard, actually, or San Jose compute sled actually carries that OCP accepted logo. It means that it is a completely open specification, and it has open design files. We have a secondary logo called OCP Inspired for other products that are available that follow those same specifications. All this information is available through our web portal. You can go to the opencompute.org and look at Marketplace and find all these products. And the last thing I want to leave you with is we have regional meetups. We just had our summit in the U.S. in March 20th and 21st. We're now expanding globally, and our next expansion is into Europe. We have a summit coming up on October 1st and 7th. Second, I'd like to invite all of you. I hope that in the near future, I'm up here talking about a summit that we're going to hold in China. So again, thank you very much. I appreciate it.